Hello, we're going to pick up yesterday where we left off on page 430. Today is May 7th, and we're going to again finish up lesson 6 in unit 12 and do pages 430, finish up 431, and if you could do on pages 433 and 434, numbers 5 through 8, and send me a snapshot in Teams. So we're going to decide why is it important if you're a credit card company that the probability of being paying your bill in full, given that you're a long-term credit card holder, is greater than the probability that you're going to pay your bill in full. That means that it's more likely that a person will pay in full each month, which is a good thing for the credit card companies. Actually not, because they're making a lot of money on the interest, but pay in full each month if they've had the credit card a while, whatever a while means, a long time. So it's just more likely that somebody's going to just keep paying their bill in full if they've held that for a long time. So it says, remember, A and B are independent if the probability of A given B is equal to the probability of A. In other words, B has nothing to do with the probability of A. Are they independent? Is the probability of F given L equal to the probability of F? Well, we've already figured out the probability of F given L is 0.548 approximately. Is that the same thing as the probability of paying your bill in full? Well, that was 0.35. 0.35, and the answer is no, not independent, because they are not equal to each other. So being a long-term credit card holder has something to do with paying your bill in full each month, and hopefully you've thought about that a little bit. Over on page 431, now we've got a credit card company in the same situation. The probability that they'll pay their bill in full each month is 35%. And the probability that a customer makes regular online purchases, that means that they use their credit card all the time online, is 0.83 regularly. And these two events are independent of each other. So it doesn't matter whether or not somebody makes online purchases. It's going to have no effect on whether or not they're going to pay their bill in full each month. So it says, what's the probability that the randomly selected customer pays his or her bill in full each month and makes regular online purchases? So we want to know, because they are independent, we know the probability. Let's see, what we're going to use F for paying in full. Let's use R for regular online purchases. So the probability of regular online purchases and paying your bill in full each month, if they are independent, then that means it's the probability of regular online purchases multiplied by the probability that you'll pay your bill in full each month. So we're asked for the probability that they pay their bill in full each month, and so we're asked for this information. So the probability that they make regular online purchases, 0.83. The probability to pay their bill in full each month is 0.35. So you just multiply those together, 0.83 times 0.35. Because they're independent, the probability is 0.2905. So, 5. So there's a 29.05% chance that they are both regular online purchasers, and they pay their bill in full each month. The next one, the student is chosen from the student body given in high school. The probability that they select math as their favorite subject, oh, it's only 1/4. The probability that the student is a junior, there must be 116 juniors in this high school out of the high school of 459 people. If the probability that they're a junior or that they choose math as their favorite subject is 47/108, what is the exact probability that the student is a junior whose favorite subject is math? That means junior and math. A junior whose favorite subject is also math. So let's see what we have here. We have the probability of math is equal to 1/4. We have the probability of being a junior is 1/16/459. And then we have the probability of J or M. That's equal to 47/108. And if you remember the OR formula is the probability of A or J plus the probability of B, but we're using an M here, minus the probability of J and M. So they want us to find this information. We have this information, we have this information, we have this information. The only thing that's missing is this here. So let's take this up here. This is 47/108 is equal to the probability of a junior, which is 1/16/459, plus the probability that they like math the best, 1/4, minus, I'm just going to call it X. It's a little bit easier to write. So if you subtract 47/108 minus this, you're going to get a negative X value. So let's do that. 47/108 minus 1/16/459 minus 1/4. Let's see if we can math frac that. Yeah. So this says a negative 31/459 is equal to negative X. So in other words, multiply both sides by -1. So 31/459, which is about 0.0675, is the probability that they are a junior and they like math. So now they're asking us, if the student's favorite subject is math and they're a junior, are they independent of each other? Let's see. Is the probability that they like math the best, multiply the probability that they are a junior, is that equal to the probability that they like math the best and they are a junior? If this is true, then they're independent of each other. So that's your question. Probability that they like math is 1/4. Probability that they're a junior is 116/459. Is that equal to what we just found, probability of math and junior, which is 31/459. Let's see. 1/4 multiplied by 116/459. Math frac. That's 29/459. Is that equal to 31/459? No, they're not equal. Their numerators are a little bit different. So it's very close, but they're not independent. And that's it. We're at the end of this lesson. So like I said, today if you could do the rest of the homework that's listed on pages 433 and 434. Have a great day.